Hi, this is section 8.4. In this section, we're going to talk about systems of nonlinear equations. So we're still going to have systems. We're still going to use substitution and elimination and see maybe some of our word problems pop up here as well. But we may not have linear equations anymore, meaning you might see something like a squared in this first example. Solve the following nonlinear equations. The first equation is y equals x squared, and the second is y equals x plus 2. Again, we can either choose substitution or elimination to solve. Remember, graphing isn't going to be an excellent choice here because it's not very accurate, although you could use that for sure to check your answers. In this first problem, I noticed that the y is already alone, so I think substitution would be a good choice. I'm going to go ahead and circle what my y is equal to, x squared in this case, then plug it in for y in the other equation. That gives me x squared equals x plus 2. Now when you have a nonlinear equation, you still have, once you do the substitution or the elimination step, all one variable, but you may have different powers, meaning you have something like a quadratic in this example. In your next step to solve a quadratic, we always get it equal to 0, and you can move everything either to the right or the left here. I'm going to move everything to the left. So I'm going to make it x squared minus x minus 2 equals 0. I moved it to the left because I like that first term to stay positive because it makes it easier to factor them. To factor this, because there's no number in front of my x squared, I'm just looking for two numbers that multiply to my last term, negative 2, and add to my middle term, negative 1. Those numbers are negative 2 and positive 1. To solve now, I set each parentheses equal to 0, zero product property, and you will get solutions of x equals 2 and x equals negative 1. So what does that mean? It means that I actually have two intersection points here. 2 something and negative 1 something, which means in the second step of our substitution, we actually have two different numbers to plug in. I'm going to plug in 2 and negative 1, and I'm going to plug them into that first equation. Y equals x squared, so y equals 2 squared will give me y is 4, so 2, 4 is my first point. And then if I plug the second point in, negative 1 squared, I'll get y equals 1. And so there are my solutions, 2, 4, and negative 1, 1. Now why are we getting two solutions here? Well, if we imagine what these graphs look like, or again, you could graph these in your calculator even pretty easily because the y's are alone. Y equals x squared is a parabola opening up, going through my origin, and y equals x plus 2 is a line that has a slope of 1 and a y-intercept of 2. So that would, rough sketch, look something like this. So you can see there are my two intersection points, two places where the parabola is touching the line, at negative 1, 1 and at 2, 4. All right, let's go ahead and move to the second one. I have x squared plus y equals 2 and 2x plus y equals 3. I'm going to use elimination for this one because in both of my equations I have a y and everything's lined up for me nicely here. You could decide if you wanted to multiply through a negative 1 and then add the equations together, but I'm just going to go ahead and subtract my equations. X squared and negative 2x, or x squared minus 2x, are not like terms, so I'm just going to bring both of those down. My y's will cancel, y minus y. And then on the other side, I have 2 minus 3, which gives me negative 1. Again, I have a quadratic. I'm going to get everything on the left, get it equal to 0. And then I'm going to factor. If I factor this, I'm looking for two numbers that multiply to 1 and add to negative 2. Those numbers are negative 1 and negative 1. Which means the only solution I'm going to get out when I set those equal to 0 is x equals 1. Which now means when I go back to my original equations, I only have one number to plug in, and I'm going to have one point of intersection. Let's say I use the bottom equation. 2 times x is 1, plus y equals 3. So I have 2 plus y equals 3, and y equals 1. So my final intersection point is 1, 1. You can check it by graphing, or again, you can check that by plugging the numbers into the original equations and make sure they work. Let's try another one. X minus y equals negative 2, and x times y equals 3. In this one, I don't have any variables alone, and I don't have any common terms between the first equation and the second equation. So probably the best bet on this one is to use substitution. You'll have a little bit of work at the beginning, get a variable alone in one of the equations. It looks like that x on top is going to be a good one to get alone. If I get that x alone, it's going to be x equals -2 plus y. And I'm going to plug that in for x in the bottom equation. So that's going to look like -2 plus y, put it in parentheses when you substitute, times y equals 3. Now I need to distribute that y into the equation, so I have -2y plus y squared equals 3. And you can see again here I have a quadratic. I'm going to get it equal to 0. I'm going to move everything again to the left because I want that y squared term to be positive. And now I can factor. If I factor this, I'm looking for two numbers that multiply to -3 and add to -2. That's a -3 and +1. So I have y values of 3 and -1. I'm going to plug both of those into the bottom equation and solve for the x that goes with them. X times 3 equals 3, so x equals 1. If I use -1, x times -1 equals 3, so that means x must equal -3. So my 2 points of intersection are 1, 3, and -3, -1. Again, graph to check. Desmos is nice if you have that available to you, or plug your solutions back in and make sure they work. Let's try the next one. 4x squared plus y squared equals 25, and x plus y equals 5. Again, I have no variable that's alone, and I don't have any like terms between the first and second equation, so I'm going to use substitution. I would get either the x or y alone in the bottom equation. Let's say I get the y alone. Y equals 5 minus x, and then that's going to go in for y in the top equation. So now I have 4x squared plus 5 minus x quantity squared equals 25. The next thing I can do to solve here is I can FOIL out my 5 minus x, so think of that like 5 minus x times 5 minus x. That's going to give me first terms 25, outside terms -5x, inside terms -5x, so total I'll have a 10x. And then last terms are -x and -x, which gives me a positive x squared. On the other side, I still have that 25. Add together my like terms. I have 4x squared and x squared, which give me 5x squared. I have a -10x. And then here, I actually have a 25 on both sides. So they're going to cancel when I get this equation equal to 0. At this point, I can factor. Now, this factoring, because I don't have a trinomial, 3 terms, we're just doing common monomial factoring, which means we're going to divide out what these terms have in common. Both terms here are divisible by a 5, and they also both have an x in them. If I divide 5x out of the first term, I'm left with an x. And if I divide 5x out of the second term, I'm left with a 2. And those are my factors. Set them each equal to 0. If I set 5x equal to 0, I get x equals 0. And if I set x minus 2 equal to 0, I get x equals +2. So x is 0 and x is 2 are the first halves of my solution. I'm going to use the bottom equation. If I have 0 plus y equals 5, I know y is 5. So my final point there is 0, 5. If I know x is 2, 2 plus y must equal 5, so y equals 3. So my final point there is 2, 3. In this one, you'll notice, again, I have no variables that are alone, but I do have common terms between the top equation and the bottom equation. Now, they're not lined up, so I'm going to rewrite this. I'm going to rewrite it instead as x squared plus 2y squared equals 12. And on the bottom, I'm going to put the negative 5x squared first, the 7y squared second, and the 8 last. There we go. Okay. We're going to use elimination to solve this. I either want to get my x's or my y's to cancel. It looks like it's probably going to be easier to get my x's to cancel if I multiply the top equation by 5. If I multiply the top equation by 5, that gives me 5x squared. Come on, x, show up, there we go. Plus 10y squared equals 60. There it goes. Now I can add my equations together. The x squareds will cancel. I'll have a 17y squared equals 68. Divide by 17. I'll have y squared equals 4. And then to solve at this point, I can just take the square root of both sides. Remember, when you take the square root, it's technically a plus or a minus. There's two numbers that are squared that are going to give me a 4. So my answers are positive and negative 2, which you can write as plus or minus 2. So now I know my solution will have two intersection points where my y is positive 2 and my y is negative 2. Let's go ahead and plug those back in and solve for x. You can use either of the original equations. I'm going to use the top equation. So let's say I plug in 2. X squared plus 2 times 2 squared equals 12. So x squared plus 2 squared gives me 4 times 2 is 8. X squared equals 4. And again, we're taking the square root, so we have a plus or minus 2. So I'm just going to put that in there right now. We'll expand that out in a second and talk about what that means. Let's say I use, again, that top equation and plug in negative 2. So negative 2 squared gives me 4 times 2 will give me 8. And hopefully you're noticing that's the exact same thing we saw a second ago. So we know we're going to get x equals plus or minus 2 there as well. So what does this mean when you plug something back in and you get two different solutions? It actually means you have more points. Those plus or minuses mean that I have 4 solutions here. My first solution is positive 2, 2. My second solution is negative 2, 2. My third solution is 2, negative 2. And my fourth solution is negative 2, negative 2. If you are wondering why we would have 3 solutions, I'll make again a rough sketch of this. That top equation represents a circle, and that bottom equation represents a hyperbola, which looks like kind of 2 parabolas back to one another. So that's why we're seeing 4 intersection points there. Okay, let's look at the next one. You can see here I have a lot of the same terms in both equations, so elimination is going to be our best option. Remember, the goal of elimination is to eliminate a variable. If I choose to eliminate the x squareds, I'll still have an x and a y. And if I choose to eliminate the x's, I'll still have an x and a y. Which means the only option I have to eliminate, so I'm only left with either all x's or all y's, are the middle terms. To eliminate the middle terms, I'm going to multiply the top equation by negative 3. That's going to give me a negative 3x squared, a positive 3xy, so that's the opposite term in the middle, that's what I want, minus 15x equals negative 12. And then I'm going to add those together. That gives me a negative x squared, xy's cancel, let's see, what was that? Oh, did I miss a number there? Hold on, back up. Back up, back up. That wasn't a 5x. That was a negative 15x. Better. Okay, 10x and negative 15x give me a negative 5x. And then on the other side, I have a negative 14. I have a quadratic. I want to get it equal to 0. I like when my first term is positive, so this time I'm going to move everything to the right. That'll give me a positive x squared, a positive 5x, and that negative 14 stays the same. Here I have a trinomial, so I'm going to factor it. I'm looking for two numbers that multiply to negative 14 and add to 5. Those numbers are positive 7 and negative 2. And if I set each of those equal to 0, I will get my x values of 7 and 2. From there, I'm going to plug those back into one of my original equations. I'll plug it into the top equation. You've got a few different places where you're going to have to plug x in here. So it's going to be negative 7 squared minus negative 7y plus 5 times negative 7 equals 4. So that's going to give me a 49 plus 7y minus 35 equals 4. That's going to give me, if I combine my 49 and my negative 35, a 14 plus 7y equals 4. Subtract 14 over, I'm going to get 7y is negative 10. So y is negative 10 sevenths. If I plug 2 into the top equation, I'll do this one in a different color, that's going to give me 2 squared minus 2y plus 5 times 2, 10 equals 4. So 4 minus 2y plus 10 equals 4. I notice here I've got 4s on both sides, so I'm just going to cancel those. Negative 2y plus 10 equals 0. Subtract 10 over, get negative 10. And then from there, divide by negative 2, I get y is 5. Final answers here are negative 7 and negative 10 sevenths. And then 2, 5 are my 2 points of intersection. Let's do a word problem. Find two positive numbers whose sum is 24 and whose product is 143. So two numbers, and they have to be positive. We want their sum, so let's call them x and y. Add them together to be 24. And then we want their product, multiplying, to be 143. And then there's our system set up. Easy one here. I'm going to solve this using substitution. Notice this looks like a problem that we did earlier in the lesson. I'm going to get the x alone in the top equation. So x equals 24 minus y. And I'm going to plug that in for x in the bottom equation. So 24 minus y times y equals 143. Distribute my y in, so that'll give me a 24y, a negative y squared, and a 143. From there, I want to get it equal to 0, and I want my y squared term to be positive, so I'm going to move everything over to the right, make it y squared minus 24y plus 143, and now we're factoring. Here we want to find two numbers that multiply to 143 and add to negative 24. You may need to do a little guess and check here. See what 143 is divisible by. The numbers we're looking for are negative 13 and negative 11, which means y is 13 and y is 11. Now what's interesting about this problem is when you go back and plug in 13 and 11, you'll get 11 and 13 out. So you actually just get the same solution twice. So the missing numbers are 13 and 11. Word problem number 2. An area of a rectangular pasture is 8,750 square feet. The pasture is divided into 3 smaller pastures by 2 fences parallel to the shorter sides. Okay, I think I need to start drawing a picture here. So we have a rectangular pasture, and we know its area. The pasture is divided into 3 smaller pastures with 2 panels parallel to the shorter sides. The width of the 2 larger pastures is the same, and the width of the smaller pasture is half of the others. So let's say I call the smaller pasture X. Get my X to show up. There we go. Then my 2 larger pastures, and by the way, it doesn't say which one's which, so I'm just calling the middle one the smaller pasture here. The 2 larger pastures, if the smaller pasture is half it, the 2 larger pastures are double. So you could say 2x and 2x. says find the possible dimensions of the original pasture if the perimeter of the smallest pasture is 190 feet. So let's go ahead and label, we don't know this length here, but we're going to call it y, and that means this would also be y, and this would also be y, and this would also be y, and this would be 2x, and this would be x, and this would be 2x. My equations can be set up two ways. The first thing I can do is write an area equation. My area is 8,750 feet. An area can be found by multiplying length and width together. If you look at the total length across, we have 2x, x, and 2x. That's a 5x. And the width here is y. The other equation is a perimeter equation. And it's a perimeter equation for the smallest pasture. The smallest pasture in the middle here, in my picture, but it really could be any of the three, is all four sides added together. So it's 190, we were told. And I have x plus y plus x plus y, which I can simplify a little bit and make it 2x plus 2y. You can simplify that equation a little bit by dividing everything by 2. That would make it 85 equals x plus y. And then I would probably solve this using substitution. So let's say I wanted to get my y alone. Y would equal 85 minus x. And I could plug that back in the top here, and I can solve for x. Go ahead and try to finish this problem on your own. Solve for x and y. Okay, if I plug 85 minus x in, I'm going to get 8,750 equals 5x times 85 minus x. If I distribute my 5x in, 5 times 85 gives me 425x minus 5x squared. It looks like everything here is divisible by 5, so let's go ahead and simplify a little bit. If I divide by 5, I get 1750. 425 divided by 5 gives me 85x, and then I'll have a negative x squared. From there, I'm going to move everything over to the right to get my quadratic equal to 0 and keep that first term positive. And now we want to factor. Here I'm looking for two numbers that multiply to 1750 and add to negative 85. So that means I'm going to be looking for two negative numbers. And it looks like 35 and 50 are the numbers I'm looking for. So x is 35, x is 50. From there, we can plug those back in to either of the original equations. Let's say I go back to my top equation, my area equation. If I plug 35 in for x, 8750 equals 5 times 35 times y. If I do 8750 divided by 5 and divided by 35, I will get 50. And I bet you can bet what's going to happen over here. 8750, if I plug in 50, 5 times 50 times y. 8750 divided by 5 divided by 50, I'm going to get y is 35. So you can see again, like that last problem, we get the same solution twice. So x is 35 and y is 50. Now going back to the problem asked find the possible dimensions of the original pasture. The original pasture then would be y, which is 50 feet, by 5x, and 5x was 35, which was 175 feet. And actually, there might be a second solution if I plug it in the other way around. Oh yeah, there is a second solution. Let's use that. So the first possible answer, if I use these two numbers, is 50 by 175. The second possible answer, if I plug in 50, so across the top, 2x, x, and 2x, I have 5 x's. It would be 250 feet by 35 feet. So 2 possible dimensions of the original pasture could make this situation possible. It's an interesting problem. Last example. A group of students chartered a fishing boat that would cost $960. Before the date of the trip, 8 more students joined the group and agreed to pay their share of the cost for the charter. The cost per student was reduced by $6. Find the original number of students and the original cost per student. So we'll say N is number of students and C is cost per student. That way I keep my variables straight. Okay, so originally it cost $960. So that means the original number of students times the cost for each student would total 960. Then, before the trip, something changed. The cost of the trip is still 960, but 8 more students joined the group. So that means my original number has increased by 8. And because of that, the cost was reduced by $6. So each student's cost went down by 6. Notice in this equation, we're still multiplying how many students are going times the cost per student to get to our 960. Okay, we can go ahead and solve now. I'm going to FOIL out on the bottom here. If I FOIL, I have an NC. Actually, I'm going to write it over here. So I have NC equals 960 on top. If I FOIL at the bottom, I have NC plus 8C minus 6N minus 48 equals 960. From there, let's see, I don't have any like terms. I could add equations together, but I'm missing a variable. It looks like that's going to get a little bit messy. Let's try this another way, maybe. Okay, I'm going to solve this problem because it's going to get a little messy if I solve with foiling. I'm going to get the n alone in the top equation. N equals 960 divided by c, and then I'm going to plug that in for n in the bottom equation. So 960 over c plus 8 times c minus 6 equals 960. And then we're going to FOIL. I'll write this out first. Outside, inside, left. My first term's 960 times c over c. The c's are just going to cancel and you have 960. My outside terms, 960 times negative 6 over c. Let's see, 960 times negative 6 is negative 5,760 over c. My inside terms are 8c. And my last terms are negative 48 equals 960. Okay, notice my 960s cancel. So I have an equation now that's equal to 0. And making that even a little bit nicer, I'm going to multiply here everything by c to get that c out of the denominator. So I have negative 5,760 plus 8c squared minus 48c equals 0. Okay, now I have a quadratic. It's all nice, pretty whole numbers. Let's see if everything's divisible by 8 there. Maybe we can reduce it a little bit. Everything is divisible by 8. So let's see, if I divide this term by 8, I just get c squared. If I divide my linear term by 8, I get negative 6c. And if I divide this guy by 8, I get negative 720. From here we can factor. I'm looking for 2 numbers that multiply to 720 and add to negative 6. One has to be positive, one has to be negative. Let's see here. Take a little guess and check maybe. 30 and 24 are my numbers. So negative 30, positive 24. Oh, don't forget my C there. And if I set each of those equal to 0, I'm going to get C is 30 and C is negative 24. Now remember, C represents cost per student, so it doesn't make sense to have a negative 24, which means the original cost per student was $30. If I go back up to my original equation, N times 30 equals 960, and divide by 30, I'm going to get N is 32. So if I'm labeling this, my original number of students was 32 students, and they each paid $30. And if you wanted to, you can always plug that back in and check it with the original information. That was a good problem as well. Your homework is the 8.4 Math Excel. It's due September 13th at 11:59 p.m. Send me questions if you have them.